Hello, welcome back to another show. This time 2022 JEE Main limits topic PYQs June and July shift. It was conducted in June and July because of the COVID. It was delayed. June and July shift they conducted JEE exams. Limits topic. There are 13 questions totally in this. We'll discuss one by one. Hope you learned all the synopsis part of this. I will discuss the synopsis in detail of limits topic. Then I've done 2019 PYQs, 2020, 21, now 2022. Take the first question. Limit n tends to infinity root of n squared minus n minus 1 plus n alpha plus beta equal to 0. Find 8 times alpha plus beta. Question asked on 25th of July, first shift 2022. Limit n tends to infinity is given to us. Correct? So, if you apply the limit directly, it won't take the proper form, I think. So, we should apply. We need to find the values of alpha and beta here. Correct? So, it might take, if alpha is negative, suppose if alpha is negative, that is, it takes infinity minus infinity form, I can tell. It's an indeterminate form. To remove the indeterminate form, I shall rationalize. Or else I can use the concept of 1 plus x whole power n. There are two methods of doing this problem. One is I can rationalize this, or else I can use 1 plus x whole power n formula, because square root is given here. Square root means to the power half, right? I'll use 1 plus x whole power n formula, okay, for n is a fraction. I'll be using that form so that I can get the answer easily. Our aim is to find the values of alpha and beta. So limit n tends to infinity. Limit n tends to infinity. First I'll write this root of n square minus n minus 1 as n square. I'll take out common. Even though it's not common, I'll take out common from there. Correct? Root of n square common. So what remains is 1 minus n by n square. Actually n square is not common. Still I'm taking out. Forcible I'm taking out. So balance it by dividing by n square for the terms. N by n square is 1 by n minus 1 by n square, correct? Like this, plus n alpha plus beta equal to 0. Root of n square is actually mod n. Mod n is n because n tends to a positive number, plus infinity I can call. So this is equal to limit n tends to infinity. Root of n square, I'll write it as n, correct? N into 1 minus 1 by n minus 1 by n square to the power half, I'll write. 1 minus 1 by n minus 1 by n square to the power half, okay, plus n alpha plus beta equal to 0. This is what is given to us, correct? Now I'll apply 1 plus x whole power n formula for n is a fraction. You know this formula, 1 plus x whole power n is 1 plus x whole to the power n is equal to 1 plus nx plus n into n minus 1 by 2x square, correct, plus n into n minus 1, n minus 2 by 6x cube, etc. up to infinity, okay, using this form. My x is this, 1 plus x is what? Minus 1 by n minus 1 by n square. It is acting as x. So I'll use this formula. I don't write all the terms. I write only few terms. Okay. My aim is to find the values of alpha and beta, right? So for that, limit n tends to infinity. N into, here applying the formula, 1 plus x whole power n. My x is what? Minus 1 by n minus 1 by n square. I should write 1 plus nx. 1 plus nx, that is minus 1 by 2n minus 1 by 2n square. I wrote half, I multiplied to that, nx, correct? N gets multiplied to x, that is what I wrote the second term, okay? Remaining terms I won't write, remaining terms are neglected because those terms if I write also is of no use, because higher terms will become 0 because n tends to infinity means 1 by n will tend to 0, correct? Because of that, I won't write all those terms. If you want to show one term there for you, that is, if you are writing one term, 1 plus nx I wrote, plus n into n minus 1 by 2 x square, correct? That means square of this, n into n is half, right? Half into half minus 1. Half into half minus 1 is minus half. So half into minus half, minus 1 by 4 by 2, minus 1 by 8 will get, correct? Minus 1 by 8 into square of this, correct? X square is there. Minus 1 by n minus 1 by n square, the whole square, correct? Rest I won't write, remaining terms and so on, plus n alpha plus beta equal to 0. Can close the bracket here. One more bracket which I opened here, okay? Like this we get. So if you multiply here, n into 1 n into 1 by 2n is half, correct? Here n into 1 by 2n square becomes minus 1 by 2n, correct? Like that. And from here onwards all the terms will become 0. From here onwards all the terms will become 0. Because n tends to infinity, 1 by n tends to 0, right? So this is n into 1 by 2n square is 1 by 2n. 1 by 2n approaches 0 because n tends to infinity, 1 by infinity is 0. Likewise here also, minus 1 by n square will be what? 1 by n square. This n into 1 by n square becomes 1 by n. 1 by n becomes 0 as n tends to infinity. And square of this minus 1 by n square is 1 by n power 4. That is multiplied to n becomes 1 by n cube. That also becomes 0. Likewise from here onwards all the terms are becoming 0. Now multiply this n inside. What we get? Limit n tends to infinity. Limit n tends to infinity. N into 1. N I can take common from these two. So n into 1 plus alpha I'll get. N into 1 plus alpha. Correct? N into minus 1 by 2n is minus half. Correct? So minus half plus beta in one bracket. So I'll write beta minus half. Beta minus half in one bracket. Remaining other terms will be equal to 0. Correct? I won't write that. Equal to 0. As n tends to infinity is there, because right hand side is already 0, I insist the condition that 1 plus alpha becomes equal to 0. Correct? 1 plus alpha should be equal to 0, because if 1 plus alpha is not equal to 0, then n tends to infinity. Correct? This becomes infinity. Infinity equal to 0 is not possible. So limit does not exist in that case. So 1 plus alpha should be equal to 0 here. 1 plus alpha is equal to 0. That means we get alpha equal to minus 1. And beta minus half should be equal to 0. So we get beta equal to half. Beta is equal to half. Correct? So we got the values of alpha and beta. Want to find 8 into alpha plus beta. 8 into alpha plus beta is equal to how much? 8 into alpha is minus 1, beta is half. Correct? Minus 1 plus half, that is minus half. 8 into minus half, that is equal to minus 4 is the answer. Minus 4. Required answer is this. Hope I understand this. Using the infinite series expansion for 1 plus x power n, where n is a fraction. If n is a fraction or negative integer, I can apply that formula. My x is this, minus 1 by n minus 1 by n square. Answer is minus 4, option C. As I told, alpha we are getting negative value. See, alpha is minus 1, so that minus n. So it takes infinity minus infinity form, as I told earlier. Because we get n alpha value is negative, it becomes n into minus 1 is minus n. So if I apply limit directly, it is taking the indeterminate form, infinity minus infinity. Correct? Solution is also given to you. Alpha is minus 1, beta is half. 8 into alpha plus beta is minus 4. If you want to look at the solution in detail, that's given. On to the next one. Limit x tends to pi by 4. If you apply limit directly, what happens is see, cos pi by 4 is 1 by root 2. Sin pi by 4 also 1 by root 2. 1 by root 2 plus 1 by root 2 is 2 by root 2. 2 by root 2 is root 2. If you apply limit directly, it becomes 8 root 2 minus, this is root 2, correct? When you apply limit directly, it becomes root 2 power 7 divided by root 2 minus root 2 into, here sine of 2 into pi by 4, pi by 2, sine pi by 2 is 1, correct? This is equal to 8 root 2 minus root 2 power 7 is also 8 root 2. So 8 root 2 minus 8 root 2 by root 2 minus root 2, that is equal to 0 by 0 form, correct? It takes 0 by 0 form. We can apply L'Hopital's rule, correct? simplify, differentiate using L'Hopital's rule. Differentiate numerator and denominator separately according to L'Hopital's rule. Applying L'Hopital's rule or L'Hopital's rule. Apply L'Hopital's rule. Differentiate numerator and denominator separately. What do you get? Limit x tends to pi by 4. Derivative of 8 root 2 is 0. Correct? 8 root 2 is constant. Derivative of cos x plus sin x power 7. Differentiate as a differentiate x power 7. Derivative of x power 7 is 7 into x power 6. Correct? 7 into cos x plus sin x to the power 6 into derivative of cos x plus sin x. Derivative of cos x is minus sin x by chain rule plus derivative of sin x is cos x divided by denominator differentiate. Derivative of root 2 is 0. Constant into variable. Constant keep as it is. Differentiate sin 2x, that is cos 2x into derivative of 2x is 2. Correct? Now we can apply the limit. Before applying the limit, you can simplify this further one more step, because if you apply limit, still it may take 0 by 0 form. Correct? See, if you apply limit at this stage, x equal to pi by 4, if you put x equal to pi by 4, cos pi by 4 is 1 by root 2. Sin pi by 4 also 1 by root 2. 1 by root 2 minus 1 by root 2 is 0. 0 into something is 0. Here 2 into pi by 4 is pi by 2. Cos pi by 2 is 0. 0 by 0 form. If you apply limit at this stage, it takes 0 by 0 form. So what I am going to do is, I'll simplify using trigonometric formula. You know cos 2x formula. Cos 2x is cos square x minus sin square x, right? Cos 2x is cos square x minus sin square x. Using double angle formula for cos 2x. Cos square x minus sin square x. What is cos square x minus sin square x? Cos x plus sin x into cos x minus sin x, right? So I can factorize it. This minus minus will cancel. That's equal to limit x tends to pi by 4. Minus minus will cancel. 7 into cos x plus sin x whole to the power 6. Correct? Multiplied by cos x minus sin x. Denominator is root 2, 2 root 2 into cos 2x is cos square x minus sin square x. It takes a square minus b square form, which is a plus b into a minus b. Split that, we get cos x plus sin x into cos x minus sin x. Cos x plus sin x into cos x minus sin x. Correct? So that cos x minus sin x will cancel from this. 1 cos x plus sin x will cancel. The power becomes 5 there. So that's equal to limit x tends to pi by 4. 7 by 2 root is constant. You can keep outside. Constant keep outside the limit. It's independent of the variable. Limit x tends to pi by 4. What is left out there? 1 cos minus sin has been cancelled. Cos plus sin cancels. What is left in the numerator is cos x plus sin x whole power 5. Cos x plus sin x whole to the power 5. Now at this stage you can apply the limit and get the answer. 7 by 2 root 2 into cos pi by 4 is 1 by root 2 plus sin pi by 4 is also 1 by root 2 to the power 5. That's equal to 7 by 2 root 2 into 1 by root 2 plus 1 by root 2 is 2 by root 2. 2 by root 2 is root 2. So root 2 power 5. Root 2 power 5. That's equal to 7 by 2 root 2 into root 2 power 5 is root 2 into root 2 power 4. Correct? So that 1 root 2 will cancel. Root 2 power 4 will be 4, correct? 7 into 4, 28 by 2. Answer is 14. Required answer is 14, option A. Simple question. Apply L'Hopital's rule because it takes 0 by 0 form. Differentiate numerator and denominator separately and use cos 2x formula, cos square x minus sin square x. Factorize this a square minus b square, a plus b into a minus b, so that cos x minus sin x will cancel out. And 1 cos plus sin cancels. The numerator will be cos x plus sin x to the power 5. 7 by 2 root 2 is kept outside. Then apply the limit and get the answer. Hope you understand this simple question. Asked on 25th of July, second shift, 2022. Solution is also given to you here. Applying L'Hopital's rule and simplifying it and getting the answer. Next one. Beta is equal to limit x tends to 0, alpha x minus e power 3x minus 1 by alpha x into e power 3x minus 1. For some alpha belongs to R, find value of alpha plus beta. Question asked on 26th of July, second shift, 2022. So whenever there is exponential function and they ask you to find alpha, beta. Normally we use the series expansion, infinite series expansion for e power x. So beta is equal to, I'll write this denominator alpha x into e power 3x minus 1 is there, no? They will multiply and divide by 3x and use limit theorem. Beta is equal to limit x tends to 0, alpha x minus e power 3x minus 1 divided by alpha x into e power 3x minus 1. Here you divide by 3x, multiply by 3x. So that e power 3x minus 1 by 3x is 1 as x tends to 0. This part will become 1. Correct? This part will approach to 1 using the limit theorem. So the denominator becomes 3 alpha x square. Then I use series expansion for e power 3x. That's equal to limit x tends to 0. What we have? Alpha x minus e power 3x minus 1 divided by 3 alpha x square. Correct? E power 3x we use a series expansion. Or else you can apply L'Hopital's rule also, because denominator is becoming 0, then numerator also should become 0. That concept also we can apply. Better than that is applying series expansion. You get the answer easily. Okay? E power 3x. Limit x tends to 0. Limit x tends to 0. What we have? Alpha x minus, right, the series expansion for e power 3x up to x square, right? Because the denominator contains x square, no? This concept we know. It depends upon the denominator. Denominator is x square, means we write the series expansion for e power 3x up till x square term. So what is e power x? 1 plus x square by 2 factorial etc. up to infinity. So e power 3x is 1 plus 3x plus 3x the whole square divided by 2 factorial etc. up to infinity. Correct? Minus 1 is there. Keep that minus 1 as it is. Divided by 3 alpha x square. Plus 1 minus 1 will add up to 0. Collect the terms with x. Collect the terms with x square etc. Go on, simplify it. What do you get? Beta is equal to, collecting the terms with x. So x, if you take common, alpha minus 3 I get. X is common, we get alpha minus 3. Correct? Then minus into plus minus. 3 square is 9. 9 by 2 x square. Also you separate the terms simultaneously. I'll divide by 3 alpha x square. Okay? Minus into plus minus. 9x square by 2. Correct? Divided by 3 alpha x square. 9x square divided by 2. That 2 comes down. 2 into 3 becomes 6 alpha x square. Correct? Next terms I am not writing. This term will contain x cube. X cube by x square become x. That x will approach 0. No? Rest all terms are 0. Rest all other terms are 0. And this is equal to, here 1x will cancel here. What we get is alpha minus 3 divided by 3 alpha x. Correct? And here 9 by 6 is 3 by 2. X square cancels. We get 3 by 2 alpha. And for limit to exist, beta is a finite number. Correct? For alpha belongs to R. Beta is some real number. It's understandable. Alpha is a real number. Beta also is a real number only. So limit of that expression is going to exist finitely. So we insist the condition that alpha minus 3 should be equal to 0. Otherwise, limit is not going to exist. Oh, sorry, I forgot to write limit here. Limit x tends to 0 is there. Limit x tends to 0. This limit x tends to 0. We insist the condition that alpha minus 3 equal to 0. Otherwise, limit does not exist if alpha minus 3 is not equal to 0. So alpha minus 3 should be equal to 0. That means alpha equal to 3. When alpha equal to 3 and this is going to become 0. So beta will be equal to this expression, the constant term which is left here. This is independent of x. Minus 3 by 2 alpha. Correct? So minus 3 by 2 into alpha we got 3. So 3 cancels. We get beta as minus half. So want to find alpha plus beta. No, therefore alpha plus beta. Alpha is 3 and beta is minus half. 3 plus minus half, that is 2.5. 2.5 is 5 by 2. Answer is option C. Just using the series expansion for e power 3x and simplifying it. And this concept we know. Numerator should become 0, otherwise limit is not going to exist. Beta is some finite number, so limit of the function is going to exist. Therefore, beta is minus half and alpha is 3. Alpha plus beta is 5 by 2. Option C is the answer. This kind of question we did many times, correct? Even in 2021 also, the questions are asked on series expansion. 2019 and 20, they not ask questions on series expansion, correct? 2020, they asked 1 to the power infinity twice, correct? So in 2021 also, one question was asked based on sandwich theorem, correct? So like that, different concepts are covered. Newton-Leibniz formulas, questions are asked on Newton-Leibniz formula even in 2019 and 20 also, even in 21 also. Newton-Leibniz formula. Series expansions were not asked. Questions based on the series expansion, infinite series expansions were not asked in 2019 and 2020. And 2021 onwards, they started asking the questions. 2021, minimum 3 or 4 questions were there on series expansion. Correct? And 2021, we had 18 questions of this chapter because they conducted in 4 shifts, 4 phases. Correct? February, March, June, and July. July and August. 4 shifts they conducted. And this 2022 only 2 shifts, June and July. Look at the solution. Solution is also given to you here. Answer is 5/2. Move on to the next one. Here also the question is based on the series expansion. Whenever you need to find the unknowns, alpha, beta, gamma, etc. and given like this, containing e power x, e power minus x, sin x, log 1 plus x, or tan inverse x, sin inverse x. In that case, normally we apply series expansion. Okay, that's the best option. Your denominator sin square x is there, no? What we do is you multiply and divide by x square first. Because sin square x by x square is 1 as x tends to 0. Because sin x by x the whole square is 1. So denominator will become x cube while you do multiply and divide by x square. Then you can apply series expansion for e power x, e power minus x and sin x. Denominator will become x cube, no? So write the series expansion for e power x, e power minus x and sin x up till x cube. Only till x cube, right? Other terms not required. Higher powers of x not required. So this is equal to limit x tends to 0. Denominator will become x cube. Hope you understand. Numerator keep as it is. X into sin square x is there, no? There we multiply and divide by x square. Divide by x square, multiply by x square. Here alpha into e power x plus beta into e power minus x plus gamma into sin x. Correct? Is equal to 2/3. This will become 1. Sin square x by x square is 1. Sin x by x the whole square. As x tends to 0, sin x by x 1. 1 square 1. Denominator is x cube. So write the series expansions for e power x, e power minus x and sin x up till x cube. What is series expansion for e power x? 1 plus x square by 2 factorial plus x cube by 3 factorial etc. up to infinity. Correct? 1 plus x square by 2 factorial plus x cube divided by 3 factorial etc. up to infinity. Plus beta into e power minus x is alternate plus minus 1 minus x plus x square by 2 factorial minus x cube by 3 factorial etc. up to infinity. Close the bracket. Plus gamma into sin x. What is series expansion for sin x? X minus x cube divided by 3 factorial plus x power 5 by 5 factorial etc. up to infinity. Correct? Whole thing is divided by x cube. Whole thing is divided by x square into x becomes x cube is equal to 2/3. Then take common terms and simplify. Collect the constant terms. Collect the terms with x square, terms with x cube. Like that go on. Combine the terms and simplify it. Limit x tends to 0. Writing the constant terms first. Constant means the terms which are independent of x. Alpha into an alpha, beta into an beta. So alpha plus beta in one bracket. Here x common. If you take x common, here also there is x. Here coefficient of x is alpha. Here coefficient of x minus beta. Coefficient of x is gamma. Correct? You divide by x cube here. Each term you divide by x cube. Divide by x cube. Next, to collect the terms with x square. X square, if you take common, what do you get? 2 factorial is 2, alpha by 2 plus beta by 2. In this third bracket, there is no x square term. Correct? Close the bracket. Divided by x cube. Each term you divide by x cube individually. Next, to collect x cube term. X cube term, if you take 1/3 factor, 3 factorial is 6. So alpha into 1/6, alpha by 6. Here, minus beta by 6. Here minus gamma by 3 factorial is 6 divided by x cube. Next term will be x power 4, no? X power 4 into something, but x power 4 you divide by x cube becomes x. X is approaching 0, no? So I won't write. All of the terms are 0. Remaining terms are equal to 0. Correct? Is equal to 2 by 3. And limit is a finite number. If you apply limit for this, denominator is becoming 0 here. Here also denominator is becoming 0. 1x will cancel. Denominator becomes x square. It is becoming 0. Limit will not exist. So we insist the condition that alpha plus beta equal to 0. Alpha plus beta is equal to 0. Here also we insist the condition that alpha minus beta plus gamma equal to 0. Here alpha by 2 plus beta by 2 should be 0. That is same as alpha plus beta equal to 0. Nothing new from this. Correct? This is the same as this. This equal to 0. Same as this equal to 0. Because alpha by 2 plus beta by 2 is 0. You multiply the entire equation by 2. Same as alpha plus beta equal to 0. I won't write that again. And this should be equal to 2 by 3. Because x cube is going to cancel. No? Limit of a constant is constant. That constant should be equal to 2 by 3. That is a limiting value actually. So this bracket will be equal to 2 by 3. I can multiply by 6 and write if you want. Alpha by 6 minus beta by 6 minus gamma by 6 is equal to 2 by 3. Correct? So solve the three equations and get the values of alpha, beta and gamma and verify which of the option is not correct they ask. Not correct they ask. So if you substitute, I can multiply this entire equation by 6. What we get? Alpha minus beta minus gamma. 2 into 6, 12. 12 by 3 is 4. Correct? That's the third equation. And we can add the two equations, I think. I will get alpha plus beta equal to 0. That's the first equation. If you take the second and third equation, what I'm going to get is I can cancel out beta. Otherwise, I'll put alpha equal to minus beta from this. Alpha plus beta 0 is alpha equal to minus beta, right? So put alpha as minus beta. Minus beta is how much? Minus 2 beta. Minus 2 beta plus gamma equal to 0. Putting alpha equal to minus beta. Minus beta. Minus 2 beta minus gamma equal to 4. If you subtract these two equations, I'll get the value of gamma, right? Minus 2 beta minus of minus 2 beta. Subtracting this and this. Gamma plus gamma, 2 gamma. 2 gamma equal to 4. I'll gamma equal to 2. I'll get gamma, 2 gamma is equal to 4, which implies gamma is equal to 2. If gamma is 2, I'll get beta from this. Gamma is 2 beta actually from the second equation there. Gamma is 2 beta, correct? That is gamma we got 2. So 2 is equal to 2 beta implies beta is equal to 1. If beta is 1, alpha is minus 1 because alpha equal to minus beta. So we get alpha equal to minus beta. So alpha is minus 1. Everything we got. Now verify one by one which of the option is not correct they ask. Alpha is minus 1, beta is 1, gamma is 2. Correct? Verify the first option. Option A is what? Alpha is minus 1, minus 1 square 1. Beta is 1, 1 square 1. Gamma is 2, 2 square 4. 1 plus 4, 6. Option A is correct. Option A is correct. Option B, verify. Alpha into beta plus beta into gamma plus gamma into alpha plus 1 equal to 0. If you want to show the first option here, A, that is alpha. Alpha we got minus 1. Minus 1 square plus 1 square plus 2 square, it is equal to 6. Option B is alpha into beta. Alpha is minus 1, beta is 1. Minus 1 into 1, minus 1. Beta is 1, gamma is 2. 1 into 2, 2. Correct? Gamma is 2, alpha is minus 1. 2 into minus 1, minus 2 plus 1 is equal to 0. Satisfies. 2 minus 2, 0. Minus 1 plus 1, 0. Option B is also correct. What about option C? Alpha is minus 1. Substitute here itself. Alpha is minus 1. Beta is 1. 1 square 1. Beta is 1. Gamma is 2. 2 square 4. Gamma is 2. Alpha is how much? Minus 1. Minus 1 square is 1 plus 3. Does it become 0 here? Minus 1 plus 4. 3. 3 plus 3. 6. 6 plus 2. 8. 8 is not equal to 0. Correct? Alpha is how much? Minus 1. Beta is 1. Minus 1. Beta is 1, gamma is 2, correct? Gamma is 2, alpha is 1, 2 plus 3, 5, 5 plus 4, 9, 9 minus 1, 8. That's not equal to 0. This is not equal to 0. Option C is not correct. You can verify option D, that is also correct. Solution is given to you. I think beta is 1, no? I got alpha is -1, beta is 1. Alpha is 1, beta is -1, gamma is -2. What is the solution I got here? Alpha is minus beta. Beta is 1. Alpha is -1, no? Beta is 1. There we got. Something mistake may be there in this calculation, or I made a mistake, I don't know. Alpha is gamma equal to 2 beta, correct? Alpha is 1, beta is -1, gamma is 2. Gamma is 2 is correct. Gamma equal to 2 beta. Any mistake happened here? Alpha is minus beta, minus 2 beta plus gamma. I think I made a mistake in this. Okay, there should be some correction here actually. Solving these equations, there's a mistake in this actually. Here I have solved it correctly. Okay, if you want, you can verify this equation. Alpha is -1, beta is 1, correct? -1, -2 plus 2, 0, correct? Here also, if you want, you can verify. Alpha is -1, beta is 1, -1, -2 equal to 4. Something has gone wrong, I think. Alpha is -1, beta is 1, -1, -2, -4. Solving the equation, something has gone wrong here. Where is the mistake? X minus x cube by 3. Oh, I made a mistake here, I think. No, it's correct. X cube. Alpha minus beta minus gamma. Alpha minus beta minus gamma. Alpha minus beta plus gamma equal to 0. Alpha equal to minus beta, right? Is correct. Alpha is minus beta is minus 2 beta plus gamma equal to 0. Here alpha is minus beta minus 2 beta. Subtracting these two, I get 2 gamma equal to -4. Oh, it's a mistake. Small mistake I've done here. Sorry. There is a mistake in this. 2 gamma equal to, it should be -4 here. Okay. 2 gamma equal to -4. So that gamma is -2. Gamma is -2. So beta is -1. Beta is -1 here. Beta is -1 and alpha is +1. That was a mistake. Small mistake done. You won't get the answer properly. Okay. Now it's correct. Now this is correct. So verification part, anyway, answer is option C itself. But this part I'll show you again. That is, this part is wrong because I interchange the values of alpha and beta. Even this part, I'll erase it. Okay. Alpha, how much we got? Alpha we got 1, correct? 1 square. Beta is how much? -1 square plus gamma is 2, -2 square. So -2 square, 4 plus 1, 6. Alpha beta plus beta gamma plus gamma alpha. Alpha is 1, beta is -1. Beta is -1, gamma is -2 plus gamma is -2 into alpha is 1, correct, plus 1. Does it become 0? This is minus 1 plus 1 cancels, plus 2 minus 2 simplifies to 0. Option B is also correct. Option C is incorrect. Alpha we got it as 1, beta is minus 1. Minus 1 square is 1, beta is minus 1, correct. Gamma is minus 2. Minus 2 square is 4. Gamma is minus 2. Alpha is 1. 1 square is 1. Correct. Plus 3. If you simplify this, 1 minus 4 minus 2. 1 minus 6. 1 minus 6 minus 5. Minus 5 plus 3 is minus 2. Correct. 3 plus 1 4. 4 minus 4 0 becomes equal to minus 2, which is not equal to 0. Small mistake had happened here. While subtracting this and this equation, I wrote 2 gamma equal to 4. Actually 2 gamma is minus 4. So gamma is minus 2. Gamma is minus 2. So beta is minus 1. Correct? Because gamma is 2 beta. So gamma is minus 2 here. Minus 2 equal to 2 beta. Correct? So that beta is minus 1. Here gamma is minus 2. Minus 2 equal to 2 beta. So beta is minus 1. Alpha is 1. Now it's correct. So even this is correct, and whatever the solution is given is also correct. Answer is C, which is not correct. Option D also you can verify it is correct. Which is not correct, they ask option C is not correct. You have to be very careful. Small mistake enough to spoil the answer. Correct? Alpha 1, beta minus 1, gamma 2. That is what we got. Alpha 1, beta minus 1, gamma minus 2. Move on to the next one. Question number 5. Limit x tends to pi by 2 tan square x into 2 sin square x plus 3 sin x plus 4 to the power half minus sin square x minus 6 sin x plus 2 to the power half. One more bracket should be there here actually. One more bracket is there, okay? And one more bracket here like this. So if you apply limit directly, no, it becomes infinity into 0 form. Takes infinity into 0 form. I'll rewrite this as limit x tends to pi by 2. Limit x tends to pi by 2 tan square x into to the power half means it is square root. Square root of 2 sin square x plus 3 sin x plus 4 minus root of sin square x plus 6 sin x plus 2. Correct? Like this. If you apply limit directly, x equal to pi by 2, tan pi by 2 is not defined. This is normally taken as infinity. And this becomes, when you put x equal to pi by 2, sin pi by 2 is 1, no? So 2 into 1 square, 3 into 1 plus 4, 2 plus 3, 5 plus 4, 9. Root 9 is 3. Here 1 square, 1, 1 plus 6, 7 plus 2, 9. Root 9 is 3. 3 minus 3 takes infinity into 0 form. Which is an indeterminate form, right? Infinity into 0. Indeterminate form. So what we do is first we rationalize this, multiply and divide by the conjugate of this. Okay, multiply and divide by root of 2 sin square x plus 3 sin x plus 4 plus root of sin square x plus 6 sin x plus 2. Multiply and divide by the conjugate and go on simplify it. Limit x tends to pi by 2, we have tan square x into what we have here, root of 2 sin square x plus 3 sin x plus 4 minus root of sin square x plus 6 sin x plus 2, correct, into root of 2 sin square x plus 3 sin x plus 4 plus root of sin square x plus 6 sin x plus 2 divided by same thing, divided by what I wrote, the same thing I'm writing here, multiplying and dividing by the conjugate 2 sin square x plus 3 sin x plus 4 plus root of sin square x plus 6 sin x plus 2. For denominator, we can apply the limit directly because there is no harm in applying the limit. If you apply limit x equal to pi by 2, you know sin pi by 2 is 1, 2 into 1 square 2, 3 into 1 3 plus 4, 3 plus 4 7 plus 2 9. This will become root 9 3 plus this also sin pi by 2 is 1, 1 square 1, 6 into 1 6, 6 plus 2 8, 8 plus 1 and root 9 is 3. Denominator is 3 plus 3 6. I can keep outside 1 by 6. And here I can use a minus b into a plus b, which is a square minus b square. So I can write this as 1 by 6 into limit x tends to pi by 2, correct? Tan square x, I'll take it to denominator, it becomes cot square x. Tan square is 1 by cot square. Here a minus b into a plus b is a square minus b square. So square of this minus square of this. Without root I'll write. So that is 2 sin square x plus 3 sin x plus 4. 2 sin square x plus 3 sin x plus 4. Correct? Minus of sin square x plus 6 sin x plus 2. Correct? Divided by denominator is I'll write 3 plus 3 6 kept outside 1 by 6. Tan square is 1 by cot square x. Cot square x. And simplify this. 2 sin square x minus sin square x is sin square x. 3 sin x minus 6 sin x is minus 3 sin x. 4 minus 2 is 2. Simplify it further and we can factorize that. Our main aim is to remove that. Now it's converted to 0 by 0 form. Correct? Actually it was an infinity into 0 form. Now it's converted to 0 by 0 form. So this is equal to, I'll write here 1 by 6 into limit x tends to pi by 2. What we have here is sin square x, correct, minus 3 sin x, 4 plus 4 minus 2 is 2, correct, divided by cot square x. If you apply limit and see, it becomes 0 by 0 form. We can apply L'Hopital's rule also here, or else I can factorize the numerator. Sin x minus 1 into sin x minus 2. I can factorize it and simplify. Any method will do. Either I can use the method of factorization, or else you can apply L'Hopital's rule at this stage. I'll use the factorization method. Write cot square as cosecant square minus 1. Numerator is sin x minus 1 into sin x minus 2. Factorizing the quadratic in sign. Denominator is cot square is cosecant square x minus 1. Because 1 plus cot square is cosecant square. And write cosecant square is 1 by sin square. 1 by sin square minus 1. Take LCM and simplify that. I'll write here that's equal to limit x tends to pi by 2. What we have? Sin x minus 1. 1 by 6 is there. I'll write 1 by 6 here inside. I forgot to write there. No, doesn't matter. Sin x minus 1 into sin x minus 2. Correct? Divided by cosecant square is 1 by sin square x, no? Is 1 by sin square x. So then take LCM, 1 by sin square x minus 1. I get 1 minus sin square x by sin square x. 1 minus sin square x divided by sin square x. Correct? And for this you can apply limit. There is no harm in applying limit for this. Sin pi by 2 becomes 1. This becomes 1. 1 square 1. So and a square minus b square. I can factorize. 1 is same as 1 square, no? 1 square. A square minus b square. A plus b into a minus b. So 1 minus sin x into 1 plus sin x. I'll write the remaining part here. 1 by 6 into limit x tends to pi by 2. What we have? Numerator is sin x minus 1 into sin x minus 2. Denominator is 1 minus sin square x, which is 1 minus sin x into 1 plus sin x. 1 minus sin x into 1 plus sin x. Correct? Here, if you cancel these two, I'll get minus 1 because they're not exactly same. Correct? 1 minus sin x is minus of sin x minus 1. If we cancel those two, I get minus 1. Now I can apply limit for this. I'll write the remaining part here. That's equal to 1 by 6 into minus 1 into, apply limit for this. Sin pi by 2 is 1. 1 minus 2 is minus 1 divided by 1 plus sin pi by 2 is 1. Correct? Minus into minus becomes plus. 1 by 6 into 1 by 2. Answer is 1 by 12. 1 by 6 into 1 by 2, which is equal to 1 by 12. Option A is the answer. Hope I understand this. The rationalize converting the infinity into 0 form to 0 by 0 form. We can apply L'Hopital's rule here at this stage, or else I am using the method of factorization. Factorize the numerator and cos square x, right? Cosecant square minus 1. Cosecant square is 1 by sine square. Then take LCM there. 1 by sine square minus 1 is 1 minus sine square by sine square. Apply limit for this denominator sine square x. Sine pi by 2 is 1. 1 square 1. So 1 by 6 into, and here sin x minus 1, sin x minus 2 kept as it is, and denominator 1 minus sin square x is 1 minus sin x into 1 plus sin x. 1 minus sin x and sin x minus 1 will cancel out to get minus 1, and apply limit for the other terms. Sin pi by 2 is 1, 1 minus 2 is minus 1, 1 plus sin pi by 2, 1 plus 1, 2. Denominator is 2 into 6, 12. Numerator is 1, 1 by 6 into 1 by 2. Answer is 1 by 12. Option E is the answer. Hope you understand this. Solution is also given to you. Detailed solution is given to you. You can look at this. Move on to the next one. The question asked, limit extends to 1 by root 2. Sine of cos inverse x minus x by 1 minus the tan of cos inverse x is equal to how much? Question asked on 26th of June, first shift, 2022. Here there is inverse trigonometric function. If you apply limit directly, it may take a 0 by 0 form. If you want to see, x tends to 1 by root 2. Cos inverse 1 by root 2 is pi by 4. Sin pi by 4 is 1 by root 2. 1 by root 2 minus 1 by root 2. It becomes 1 by root 2 minus 1 by root 2. Applying the limit directly. 1 minus and tan of cos inverse 1 by root 2. What is cos inverse 1 by root 2? Pi by 4. Tan pi by 4 is 1. So it takes 0 by 0 form. We can apply L'Hopital's rule, but I'll avoid using the L'Hopital's rule. I'll simplify using the concepts of inverse trigonometry. Cos inverse x I'll convert it to sin inverse, and here cos inverse x I'll convert it to tan inverse, so that I can simplify it easily. So this becomes equal to limit x tends to 1 by root 2. Limit x tends to 1 by root 2. What I am writing is sine of, what is cos inverse x in terms of sine. If you want to take a triangle and mark the angle as alpha, cos inverse x, if you take it as alpha here, cos inverse x is equal to alpha, correct? That means cos alpha is x. Cos alpha is equal to x. X means x by 1. Cos is adjacent side by hypotenuse. So opposite side will be root of 1 minus x square. So if you define sin alpha from this triangle, sin alpha is opposite by hypotenuse, root of 1 minus x square, correct? Sin alpha is root of 1 minus x square. So alpha is equal to what? Sin inverse of root 1 minus x square. Alpha is sin inverse root of 1 minus x square. So alpha is cos inverse x. Alpha is also sin inverse root 1 minus x square. So I can conclude that cos inverse x is same as sin inverse of root 1 minus x square. This kind of concepts are used in inverse trigonometric function, expressing one inverse trigonometric function in terms of other. Minus x divided by 1 minus tan of, convert this cos inverse x to tan inverse. Can you define tan alpha in this triangle? In the same triangle, tan alpha is equal to what? Opposite by adjacent, right? Root of 1 minus x square divided by x. Opposite side divided by adjacent side. So alpha is equal to what? Tan inverse of root 1 minus x square divided by x. Tan inverse root of 1 minus x square divided by x. So tan inverse root 1 minus x square divided by x. Using the concept of inverse trigonometry, I can simplify it as sin inverse root 1 minus x square is root 1 minus x square. So we get limit x tends to 1 by root 2. Limit x tends to 1 by root 2. What do you get? Root of 1 minus x square minus x divided by 1 minus tan inverse root 1 minus x square by x is root of 1 minus x square divided by x. Now take LCM and simplify. Limit x tends to 1 by root 2. Denominator take LCM there. LCM is x. So this will be x minus root of 1 minus x square. Correct? Here it is root of 1 minus x square minus x. If we cancel these two, I'll get minus 1. Minus 1 by x. That is minus x. So I'm getting limit x tends to 1 by root 2 of minus x. Correct? Because 1 by x is x. So minus x. Apply limit x equal to 1 by root 2. We get minus 1 by root 2 as answer. Option D is answer. Express one inverse trigonometric function in terms of other. Cos inverse x is sin inverse of root 1 minus x square, and cos inverse x is tan inverse root 1 minus x square by x. And take LCM and simplify, then apply the limit to get the answer. Minus 1 by root 2 is the answer. Option D. Solution is also given to you here. Move on to the next one. Question number 7. Limit x tends to 0. cos of sin x minus cos x divided by x power 4 is equal to how much? If you apply the limit directly, definitely it takes 0 by 0 form. And applying L'Hopital's rule is not so easy. It takes more time consuming it becomes, because x power 4 is there, no? We need to differentiate again and again. Again and again you should apply L'Hopital's rule if you're applying that method. So I will avoid using the L'Hopital's rule. First of all, what we'll do is apply the transformation formula, that is factorization formula, cos c minus cos d. Do you know the formula? Cos c minus cos d is equal to, cos c minus cos d is equal to what? Minus 2 sin c plus d by 2 into sin c minus d by 2. Applying this factorization formula, correct? Cos c minus cos d is equal to minus 2 sin c plus d by 2 into sin c minus d by 2. I'm using this formula. Okay, so that's equal to limit x tends to 0. What do you get? Minus 2 sine of, my angle C is this, sin x. Angle C is sin x, angle D is x. Okay, cos C minus cos D, minus 2 sin C plus D by 2 into sin C minus D by 2, minus 2 sin x plus x divided by 2 into sin of sin x minus x by 2. Divided by x power 4. Now we know that sine of an angle by same angle is 1, right? What is the angle present here? Sin x plus x by 2. As x approaches to 0, this angle is tending to 0, right? As x approaches to 0, what we have? Sin x plus x divided by 2 is approaching 0, right? Sin 0, 0. 0 plus 0, 0. 0 by 2, 0. Even as x tends to 0, sin x minus x also becoming 0, right? Sin x minus x divided by 2, that is also approaching 0. 0 minus 0 by 2 is 0. So both the angles are tending to 0. So sine of an angle by same angle is 1. Limit theta tends to 0. Sin theta by theta is 1, we know. So what we'll do is multiply and divide by, here divide by sin x plus x by 2. Okay, here divide by sin x minus x by 2, the denominator is multiplied by sin x plus x by 2 and sin x minus x by 2. To balance it, numerator also multiply by sin x plus x by 2, sin x minus x by 2. Like this. Now use this sine of an angle by same angle is 1. Sin theta by theta is 1 as theta tends to 0. This also becomes 1. Sine of an angle by same angle is 1. Correct? These two is approaching 1. And here minus 2 you can keep outside. Here 2 into 2 is 4. Otherwise 1, 2 will cancel here. This 2 and 2 will cancel. Minus half you can keep outside. Minus half into, what is left? Limit x tends to 0. Here use a plus b into a minus b. A square minus b square. Correct? Sin x plus x into sin x minus x is sin square x minus x square. Sin square x minus x square divided by x power 4. Correct? Now to evaluate this limit, I can use the series expansion for sin x. I can apply L'Hopital's rule 0 by 0 form definitely, but it is time consuming. Okay, it becomes lengthy. So I'll use series expansion for sin x. What is series expansion for sin x? X minus x cube by 3 factorial plus x power 5 by 5 factorial, etc. up to infinity. And I can write up till x power 4 because denominator is x power 4, right? So that's equal to minus half into limit x tends to 0. Limit x tends to 0. What is sin x? X minus x cube divided by 3 factorial plus x power 5 by 5 factorial, etc. up to infinity. The whole square minus x square divided by x power 4. Now if you expand this, if you expand only the first two terms you consider and square it. Okay, third term is not required because if you use a plus b plus c whole square, I'll get here square of this. X power 5 square will be x power 10, correct? X power 10 by x power 4, if you separate, you divide it, you get x power 6. And x power 6 will become 0 as x tends to 0. So higher powers neglected, it becomes 0 as we did earlier also many times. So here expand, square it only by taking the first two terms. What is a minus b whole square? Square of this plus square of this minus 2 times this into this. Correct? Only that much is enough. Rest other terms are higher terms, will have higher powers of x, will have more than x power 4, terms with more than x power 4, x power 5, x power 6, etc. Such term will vanish, becomes 0, because x power 5 by x power 4 is x. X is approaching 0, right? Numerator is becoming 0 there. So all other terms will become 0. Even x power 6 is present also. X power 6 by x power 4 will be x square. X square is approaching 0. So I won't write all those terms. I'll write only the first two terms square. So that is equal to minus half into limit x tends to 0. What I am going to write in the numerator is x square plus x cube by 3 factorial square. X cube square is x power 6. 3 factorial is 6. 6 square is 36. Correct? Minus 2ab part. 2ab part is how much? 2 into x cube by 3 factorial. X into x cube is x power 4. 3 factorial is 6. 2 by 6, 1 by 3. That is x power 4 divided by 3. Correct? Divided by 3. Other terms neglected and so on, right? Minus x square divided by x power 4, and here see x square and minus x square will cancel, and I need only up till x power 4. X power 6 also not required, because x power 6 by x power 4 becomes x square, and x square is becoming 0 because limit x tends to 0 is there. So finally I'm getting an answer now at this stage. Minus half into, when you divide this by this, x power 4 is going to cancel. This will become 0 as x tends to 0, because when you divide this by this, it becomes x square. X square is becoming 0. 0 by 36 is 0. Rest all terms which I didn't write, those terms also become 0. And here x power 4 is going to cancel. Minus 1 by 3. It's a constant. Limit of a constant is constant. So I'm getting minus half into minus 1 by 3. Answer is 1 by 6. Answer is option C, 1 by 6. Hope I understand this. This kind of question is present even in the Singhage book. I've seen this exactly same question, and also given in terms of cos of tan x, I think. Instead of sin x, they're given tan x also. That also important. Work out the same type of question. Some questions are found exactly in some of the books. Okay. Normally they set the question so that it is not found in any of the books. Most of the questions will be like that. But sometimes we can see exactly same question are present in some of the books. Okay. So question asked on 26th of June, second shift, 2022. Answer is 1 by 6, option C. If you want, you can look at the detailed solution given to you. Next one, let a be an integer such that limit x tends to 7 of 18 minus greatest integer value of 1 minus x by integral value of x minus 3 exists. Find the value of a. Question asked on 27th of June, first shift, 2022. Can you do? Limit of the function is going to exist. When does limit exist? Limit exists only if left hand limit becomes equal to right hand limit, correct? So that concept I should apply. Left hand limit equal to right hand limit, so that I can get the value of a. Can you try? Limit of the function exists implies left hand limit equal to right hand limit. Left hand limit equal to right hand limit. Left hand limit is limit x tends to 7 minus, correct, of this expression. 18 minus greatest integer value of 1 minus x, greatest integer value of 1 minus x divided by, because they told a is an integer, I can write integral value of x minus 3 as integral value of x minus 3a. Because a is an integer, even 3a is an integer, correct? Right hand limit, limit x tends to 7 plus, limit x tends to 7 plus of this expression. 18 minus greatest integer value of 1 minus x divided by integral value of x minus 3a. Because a is an integer, a is also integer, I am using this property of greatest integer function. Greatest integer value of x plus n is equal to greatest integer value of x plus n for all n belongs to z, set of integers. I can use this. So that's how I wrote this. Integral value of x minus 3 is integral value of x minus 3a. Here also same thing, integral value of x minus 3a. Now take a value of x tends to 7 minus. 7 minus means what you understand? The value of x is slightly less than 7. So 6.9 you take. Integral value of 6.9 is 6. Here 1 minus 6.9 you do. Take x equal to 6.9 in your mind. Okay, 6.9 you take. 1 minus 6.9 is minus 5.9, correct? Taking x equal to 6.9, if you take x equal to say 6.9 you take. What is 1 minus x? 1 minus x, 1 minus 6.9 is minus 5.9, correct? What is integral value of minus 5.9? Integral value of minus 5.9 is minus 6, correct? Immediate integer less than minus 5.9 is minus 6. I am applying the limit now. So this becomes 18 minus, correct? I take an example for 7 minus as 6.9. You can take a number which is close to 7, just less than 7. 6.9 I took. 1 minus 6.9 is minus 5.9. Integral value of minus 5.9 is minus 6. Correct? And for x equal to 6.9, integral value of x is 6 minus 3a is equal to, for 7 plus, take a value of x slightly greater than 7, 7.1. If you take x equal to 7.1, if you take x equal to 7.1, what is 1 minus x? 1 minus x will be 1 minus 7.1, that is minus 6.1. Integral value of minus 6.1. Immediate integer less than minus 6.1 is minus 7. So that is equal to, this will be 18 minus integral value of 1 minus x is minus 7 divided by integral value of x. Integral value of 7.1 is 7 minus 3a. Correct? This is how much? 18 plus 6, 24 divided by 6 minus 3a is equal to 18 plus 7, 25 divided by 7 minus 3a. Rest part is just simplification. Only the important part is how to apply limit for the greatest integer value of x and greatest integer value of 1 minus x. Only that is the important step. On cross multiplication, 24 into 7 is 168 minus 24 into 3a, that is 72a. Correct? Here 6 into 25, 150 minus 3a into 25, that is minus 75a. Correct? 168 minus 150, that is 18. Here minus 75a plus 72a, that is minus 3a, that is a equal to minus 6. Value of a is minus 6. Option A is the answer. Simple question asked on 27th of June, first step 2022. Learn how to evaluate the greatest integer value of x and greatest integer value of 1 minus x. I have given an example here to understand. For understanding purpose, I have taken a rough value, slightly less than 7 as 6.9, slightly greater than 7 as 7.1. To make you understand, I have given it as an example. Okay, and evaluating it and cross multiply and get the value of a as minus 6. Option A is the answer. Hope you understand this. Solution is also given to you. Detailed solution is given to you. Next one, question number 9. The value of limit n tends to infinity. Here also there is an inverse trigonometric function. This kind of question is commonly asked in IT of chapter. Inverse trigonometry function. R square plus 3r plus 3. That you have to simplify. We are familiar with the formula tan inverse of x minus y by 1 plus xy. This is a formula I am going to apply. Tan inverse of x minus y by 1 plus xy is equal to tan inverse x minus tan inverse y. Tan inverse x minus tan inverse y. I am using this formula. This is for x into y is greater than minus 1. Condition is there. Okay. I am using this formula to simplify this. Condition is r is equal to 1 to n. There are n terms. Limit n tends to infinity is there. How to simplify this? Look at this denominator, r square plus 3r plus 3. I will write this in this form, 1 plus xy. How to write r square plus 3r plus 3? Look at this, r square plus 3r plus 3. I can write it as 1 plus r square plus 3r plus 2. And I can factorize this bracket as r plus 1 into r plus 2. R plus 1 into r plus 2. Okay. So, and the numerator 1 is there. Now I can write it as r plus 2 minus r plus 1. Writing the numerator 1 as r plus 2 minus of r plus 1. R minus r is 0. 2 minus 1 is 1, right? So this, if you write 1 as r plus 2 minus r plus 1 and r square plus 3r plus 3 as 1 plus r plus 1 into r plus 2, it is taking this form, x minus y by 1 plus x. I hope you understand. If I get the terms inside the bracket in this form, tan inverse x minus y by 1 plus xy, I could write it as tan inverse x minus tan inverse y. And we can apply the summation r is equal to 1 to n, sum of the terms varying from r equal to 1 to n, and many of the terms are going to cancel, only 2 terms will remain. That's the idea whenever you get expression of this type. It's a commonly asked question in ITF chapter. Many questions are there connected to this. Here one extra concept is applying limit for that. Okay, this question can also be taken in ITF chapter also. Only extra part is limit is there. I've taken it here itself in a limit chapter. So I'm simplifying this. That's equal to limit n tends to infinity 6 into tan of summation r is equal to 1 to n tan inverse of numerator, what I am writing, 1 as r plus 2 minus r plus 1, r plus 2 minus of r plus 1, correct. Denominator 1 plus r plus 1 into r plus 2, or r plus 2 into r plus 1, both same, like this. Hope you understand. Now it is taking which form? Tan inverse of x minus y divided by 1 plus xy. My x is r plus 2 and y is r plus 1. So I can use this formula. From this I am getting this, coming from this to this. So this will be what? Tan inverse of r plus 2 minus tan inverse of r plus 1, using this. In place of x I got r plus 2, in place of y we got r plus 1, correct. So this is equal to limit n tends to infinity, limit n tends to infinity 6 into tan of summation r is equal to 1 to n tan inverse of r plus 2 minus tan inverse of r plus 1. Hope you understand this. And you should apply the summation for all this. For both the terms, apply summation r equal to 1 to n. Put r equal to 1, we get the first term. R is equal to 2, we get the second term. Put r is equal to 3, we get the third term. Put r is equal to n, we get the nth term. And many of the terms are going to cancel that. It's equal to limit n tends to infinity 6 into tan of, applying summation now, r is equal to 1, what we get? Tan inverse of r is 1 plus 2 3 minus tan inverse of, put r is equal to 1 plus 1 2, correct. Next put r is equal to 2 plus 2 4, tan inverse of 4 minus tan inverse of, putting r is equal to 2 plus 1 3, like that. Continue, put r is equal to 3, I get 3 plus 2 5, tan inverse 5 minus tan inverse of 3 plus 1 4, like this. Go on, continue, and so on. 3 dots indicates and so on. Put r is equal to n, we get tan inverse of r is equal to n, you put n plus 2 minus tan inverse of, putting r is equal to n, we get n plus 1, correct. See, tan inverse of 3 is going to cancel, tan inverse of 4 is going to cancel with the next term. Last but one term will be tan inverse n plus 1 minus tan inverse n. Tan inverse of n plus 1 is going to cancel. What will not cancel is only 2 terms, tan inverse of n plus 2 minus tan inverse of 2. So that's equal to limit n tends to infinity, limit n tends to infinity 6 into tan of, what is left? Tan inverse n plus 2 minus tan inverse 2. Tan inverse of n plus 2 minus tan inverse of 2. Now use tan inverse x minus tan inverse y formula. Tan inverse of x minus y by 1 plus xy. Again, from right to left, I'm combining this. From this, I'm coming to this. Tan inverse x minus tan inverse y. Tan inverse of x is n plus 2, minus tan inverse of y is 2. Correct? That's equal to 6, you can keep outside. Limit n tends to infinity. 6 is a constant, independent of n. Tan of tan inverse, what I'm getting here? N plus 2 minus 2 divided by 1 plus n plus 2 into 2. Correct? Tan inverse of x minus y by 1 plus xy. Tan of tan inverse of that expression is that expression only. So tan of tan inverse will cancel out, as speaking in your language. That's equal to what we get? 6 times limit n tends to infinity, what we have here, plus 2 minus 2 cancel, n by 1 plus 2n plus 4. This is 2n plus 4. 4 plus 1, 5. So I'm getting 2n plus 5. Correct? 2n plus 5. Now this is equal to 6 into. Now limit n tends to infinity of this. Numerator is a polynomial of degree 1. N power 1, right? Denominator also polynomial of degree 1. Correct? Both have same degree. Numerator and denominator have same degree. So limiting value is nothing but the ratio of the leading coefficient. What is coefficient of n in the numerator? 1. What is coefficient of n in the denominator? 2. 6 into half, 3. That's the answer. Option C. Hope I understand this. Is that clear? Repeatedly applying this formula. Tan inverse of x minus y by 1 plus x5. Tan inverse x minus tan inverse y. Important step is this. Writing r square plus 3r plus 3s 1 plus r square plus 3r plus 2. R square plus 3r plus 2 is r plus 1 into r plus 2. And writing the numerator 1 as r plus 2 minus r plus 1. Tan inverse of x minus y by 1 plus x5. Tan inverse x minus tan inverse y. Go on, simplify it. And many of the terms will add up to 0. Only 2 terms will remain at last. Then again apply the formula tan inverse x minus tan inverse y and simplify it. Then apply the limit to get the answer. Answer is 3, option C. Solution is also given to you. Detailed solution is given to you. Please make a note of this. Move on to the next one. Question number 10. The value of limit x tends to 1. X squared minus 1 into sine square of pi x divided by x power 4 minus 2x cube plus 2x minus 1 is equal to how much? Question asked on 29th June, second shift, 2022. If you apply the limit directly, no, it takes 0 by 0 form, definitely. Put x equal to 1 directly. 1 square 1, 1 minus 1, 0. Here sine pi is 0, correct? Putting x equal to 1. Denominator 1 minus 2 plus 2 minus 1 becomes 0. 0 by 0 form. Indeterminate form. Correct? So our aim is to remove this indeterminate form. And numerator x square minus 1, I can factorize it as x plus 1 into x minus 1. And denominator is a polynomial of degree 4, no? X power 4 is there. So denominator is a polynomial of degree 4. It has 4 roots at the most. So, and the first root is got by method of inspection. Obviously, x equal to 1 satisfies. When you put x equal to 1, 1 minus 2 plus 2 minus 1 becomes 0. Correct? So it takes 0 by 0 form, and I can tell x equal to 1 satisfies the denominator, means x minus 1 should be the factor by remainder and factor theorem. If x equal to alpha is a root, then x minus alpha should be a factor. Correct? If you put x equal to 1, x power 4 minus 2x cube plus 2x minus 1 is becoming 0. Correct? 1 minus 2 plus 2 minus 1, minus 2 plus 2 0, 1 minus 1 0. Putting x equal to 1, it becomes 0, right? Therefore x minus 1 should be the factor. X minus 1 should be the factor here. So what do you have? X power 4 minus 2x cube plus 2x minus 1. You divide this by x minus 1. Okay, x into x cube will give x power 4, correct? Minus 1 into x cube is minus x cube. Change the sign. You know how to divide. Minus plus. This will cancel. Minus 2x cube plus x cube becomes minus x cube plus 2x minus 1. Correct? X you have to multiply by minus x square to get minus x cube. Minus 1 into minus x square plus x square. Correct? Minus plus, I can change the sign. Minus x cube plus x cube cancels. We get minus x square plus 2x minus 1. X have to multiply by minus x in order to get minus x square. Correct? Minus 1 into minus x plus x. Change the sign. Plus minus. This will cancel. 2x minus x is x. X minus 1. X minus 1 you multiply by 1. You get x minus 1. Change the sign. Minus plus becomes 0. Correct? So this is other factor. Because the remainder is 0. Product of these two will be equal to this. You know, dividend is equal to divisor into quotient plus remainder. Remainder is 0. Means the product of these two will give this. Dividend is divisor into quotient. So if you multiply these two, you'll get this. And this is the other factor. And here x cube minus x square minus x plus 1. From this, I can take the first two terms, x square is common. Correct? So that x minus 1 remains. And here next two terms minus 1 is common into x minus 1. So again x minus 1 is common. So what remains is x square minus 1. So that means the product of x minus 1 into x minus 1 into x square minus 1 gives this, correct? Product of this and this will give this. This is simplified to this. So product of this and this and this will give this. So denominator I can write it as limit x tends to 1. Denominator is what? Denominator is x minus 1, correct? Into x minus 1, which is x minus 1 the whole square, into x square minus 1, correct? Numerator is x square minus 1 into sine square of pi x. X square minus 1 is going to cancel. X square minus 1 cancels. Now as x approaches 1, numerator and denominator both are approaching to 0. So 0 by 0 form, we can apply L'Hopital's rule, one method. Otherwise I can use trigonometric concept here. Sine square of pi x. I can write sine square theta is same as sine square pi minus theta, no? So I can write this as sine square of pi minus pi x divided by x minus 1 the whole square. Because sine theta is same as sine of pi minus theta, you know this. Sine of an angle is same as sine of its supplement angle. Sine theta equal to sine of pi minus theta. Sine square theta equal to sine square of pi minus theta. So that's equal to limit x tends to 1. Limit x tends to 1. What do you get? Sine square of, here you take pi common, you get 1 minus x. Correct? And x minus 1 the whole square is same as 1 minus x the whole square. Correct? Sine square of an angle by same angle is 1, no? As x is approaching to 1. So what I'll do is the angle present is pi into 1 minus x. We know x minus 1 the whole square is same as 1 minus x the whole square, correct? 3 square is same as minus 3 square, like that. So now the angle present is pi into 1 minus x. You multiply and divide by pi square here. Multiply and divide by pi square. So this part will become 1. Sine square theta by theta square is 1, correct? Limit theta tends to 0. We know that sine theta by theta is 1. So sine square theta divided by theta square is same as 1 square, it's equal to 1. So what is rounded off is 1. So what is left out is 1 into pi square is equal to pi square. Simple question, not a big deal at all. Answer is option D. Hope you understand. Here I use sine square theta equal to sine square pi minus theta, because sine theta equal to sine pi minus theta. Pi is common, 1 minus x. Sine square of pi into 1 minus x it becomes. And x minus 1 the whole square is same as 1 minus x the whole square. What is the angle present here? Pi into 1 minus x. Square of that should be present in the numerator denominator. So that sine square theta by theta is 1 using this. Correct? Now 1 into pi square is pi square. Option D is the answer. Look at the solution is given, option D. Look at the next one. Numerical type question here. Last 3 questions are there, 11, 12, 13. They are numerical type question asked in year 2022, 28 July, first shift, 2022. Here limit x tends to 0 is there and the power is 100 by x. 100 by 0. If you apply limit, no, 100 by 0 is infinity. And you apply limit directly for this x equal to 0. 0 plus 2 into cos 0. Cos 0 is 1. 0 plus 2. 2 cube is 8. Correct? And denominator, numerator is what is becoming here? 0 plus 2 into cos 0. Cos 0 is 1. 1 into 2, 2. 2 plus 0 is 2. 2 cube is 8. Correct? 2 into 0 plus 2. Correct? 0 plus 2 into cos 0. Cos 0 is 1. 1 into 2, 2. 2 plus 0, 2. 2 square. Plus 3 into sine of 0 plus 2 into cos 0. Cos 0 is 1. It becomes 3 into sine of 0 plus 2, 2. Correct? Denominator is what? 0 plus 2, 2. 2 cube is 8. Plus 2 into 0 plus 2, 2 square. Correct? Plus 3 into sine of 0 plus 2. 0 plus 2 is 2. 3 into sine 2. This entire thing is raised to the power 100 by 0. Numerator is same as denominator, no? So it becomes 1. And 100 by 0 is infinity. Takes 1 to the power infinity form. Takes 1 to the power infinity form. Correct? We know 1 to the power infinity form is a familiar formula. Correct? Whenever 1 to the power infinity is there, we use the formula limit x tends to a f of x for g of x as e power limit x tends to a g of x into f of x minus 1. So I'm using that formula. Before applying that formula, what we'll do is we see the important observation in the numerator x plus 2 cos x is present everywhere in the bracket. So you name a is equal to x plus 2 cos x for simplicity's sake. Take a as x plus 2 cos x, and in the denominator you can see each bracket contains x plus 2, x plus 2, x plus 2. So take b is equal to x plus 2 for convenience. Okay, and apply the formula 1 to the point infinity formula. What is the formula we have? E power limit x tends to 0 g of x into f of x minus 1. My g of x is 100 by x, g of x into f of x minus 1. F of x is this entire thing minus 1. I named this as a, no, x plus 2 cos x as a, so I'll write a cube. Okay, a cube plus 2 times a square plus 3 times sine a divided by, this is b cube plus 2 into b square plus 3 into sine of x plus 2 is b minus 1, like this entity. I have named x plus 2 cos x as a for simplicity's sake and x plus 2 as b. Okay, I apply the formula e power limit x tends to 0 g of x, the power g of x into f of x minus 1. Of course, a and b are functions of x only. I can call this as f of x minus 1. Now take LCM inside the bracket. Is equal to e power limit x tends to 0. What we have? 100 by x, correct? Taking common denominator here, what we get? B cube plus 2b square plus 3 sine b, correct? And when you take LCM here, this entire thing comes here, correct? A cube minus b cube. I'll group the terms and write a cube minus b cube, correct? Plus 2 times a square minus b square plus 3 times sine a minus sine b. Like this. See, observe that as x is approaching to 0, a is approaching what? As x approaches to 0, a approaches to what? X is becoming 0. Cos 0 is 1, 1 into 2, 2, 0 plus 2, a approaches to 2, correct? As x approaches to 0, a approaches to 2. And what about b? B also approaches to 2, no? 0 plus 2 is 2. As x approaches to 0, a is approaching 2. A means this, x plus 2 cos x. Put x equal to 0. 0 plus 2 into cos 0. Cos 0 is 1, 1 into 2, 2, 2 plus 0 is 2. Even b is approaching to 0 plus to 2. A and b both are approaching to 2. So a cube minus b cube is 0, no? A cube is approaching 8, b cube is approaching 8. 8 minus 8, 0. A square minus b square also 0, because a is approaching to 2 square 4, b is approaching to 2 square 4, 4 minus 4, 0. Sine 2 minus sine 2, 0. This entire thing is gone, 0, correct? 0 by some non-zero number is 0. 0 into 100 is 0 into some number. 100 by a small positive quantity you can take. 100 by 0 is some very huge number. That number into 0 is 0. That is equal to e power 0. E power 0 is 1. So required answer is 1. It's quite simple question. Looks lengthy, looks big one, but the answer is so simple. E power 0 is 1. Because this numerator part is 0. 0 into some finite number is 0. And e power 0 is 1. Solution is given to here, e power 0, that's equal to 1. Next one, square bracket t denote the greatest integer less than or equal to t, and the floor bracket t denote the fractional part of t. This is the floor bracket t is given, that's the fractional part function. Integral value of alpha you have to find out, for which the left hand limit of the function f of x is given like this. Left hand limit of the function is given at x equal to 0 as minus 4 by 3. You have to find the value of alpha. Integral value of alpha I have to find out. Integral value of alpha I have to find out. Question asked on 27th of June, second shift, 2022. Take f of x as this and find the limiting value. Left hand limit you have to find out. Left hand limit at x equal to 0 you have to find out. That is given to be equal to minus 4 by 3. You have to find the integral value of alpha. So limit x tends to 0 minus. Limit x tends to 0 minus of greatest integer value of 1 plus x plus alpha to the power 2 into integral value of x plus fractional part of x plus integral value of x minus 1 divided by 2 into integral value of x plus fractional part of x. This much is given to be equal to minus 4 by 3. X tends to 0 minus of this function is given to be of this expression is given to be equal to minus 4 by 3 to find the integral value of alpha. Whenever there is fractional part function, greatest integer function, what we do, we know when you are finding the left hand limit at x equal to 0. 0 minus means slightly less than 0, right? So x tends to 0 minus means what? We put x equal to 0 minus h, where h is a small positive quantity. This is a method we did many times already. We are familiar with this. In 2019 paper, 3 questions were asked based on this left hand limit and right hand limit questions, where it involves the greatest integer function and modulus function. In 2022, 1 question is asked, such kind of question. Because they put x, they told x tends to 0 minus, what we do? Put x equal to 0 minus h. Put x equal to 0 minus h, where h tends to 0, using this technique. Okay? Put x equal to 0 minus h, where h tends to a small positive quantity very close to 0. 0 plus actually, but I wrote 0. It's understandable. Okay, so instead of putting x tends to 0 minus, you put h tends to 0. Limit h tends to 0, and wherever there is x, you put minus h and evaluate it. So what do you get? Limit h tends to 0. Limit h tends to 0. Integral value of 1. In place of x, I should put minus h. 0 minus means 0 minus h, where h is small positive quantity close to 0. Correct? 0 minus h. So put x equal to minus h. Wherever there is x, you put minus h. Alpha to the power 2 into integral value of minus h plus fractional part of minus h plus integral value of minus h minus 1, correct, divided by 2 into integral value of minus h plus fractional part of minus h, that's given to me equal to minus 4 by 3, correct. H tends to 0 is given. Take a small positive value, say 0.1 you take in the mind, okay, for convenience. 1 minus 0.1 is how much? 1 minus 0.1 is 0.9. Integral value of 0.9 is 0, correct? Putting h equal to 0, this will become 0, correct? Wherever there is h, you put h equal to almost 0, 0.1 you put, 1 minus 0.1 is 0.9, integral value of 0.9 is going to be equal to 0. So 0 plus alpha to the power 2 into integral value of minus h, as h tends to 0. Put h equal to 0.1 in the mind. Integral value of minus 0.1. Integral value of minus 0.1 is minus 1. 2 into minus 1 it becomes. And in fractional part of minus h. You know, fractional part of minus 0.1. What is fractional part of minus 0.1? Fractional, first I'll give examples for fractional part of 1.7. Fractional part of 1.7 is 0.7. Hope I understand. The decimal part present in that. Fractional part of, suppose I ask 1.2, it is equal to 0.2. Okay. Suppose what is fractional part of 5? Fractional part of 5 is 0. There is no fractional part, only integral part is there. So fractional part of x actually by definition is given to be equal to x minus greatest integer function. Actually it is x minus greatest integer function. While finding the fractional part of minus 0.1, many students make a mistake. They'll write it as 0.1 or minus 0.1 etc. That is wrong. Okay, apply this definition of fractional part of x, x minus greatest integer value of x. Suppose you want to find fractional part of minus 0.1, it is equal to minus 0.1 minus integral value of minus 0.1. That is equal to minus 0.1 minus integral value of minus 0.1 is minus 1. Minus of minus plus 1. 1 minus 0.1 is 0.9. That's the answer. So fractional part of x means x minus greatest integer function. You must know this if you want to make a note of this. Fractional part of 1.7 is 0.7. Fractional part of 2.0 is 0. Fractional part of 10 is 0. Fractional part of any integral value is 0. Okay. Fractional part of 1.2 is 0.2. If I have a fractional part of 1.5, it is 0.5. Fractional part of 2.33 is 0.33. Hope I understand. Fractional part of 0 is 0. Fractional part of minus 1 is 0. Suppose you want fractional part of minus 1.7. It is not 0.7. It is not minus 0.7. It is 0.3. Fractional part of, suppose you want minus 1.7. How do you compute it? That is equal to minus 1.7 minus integral value of minus 1.7. That is equal to minus 1.7 minus integral value of minus 1.7 is minus 2. Minus of minus 2 plus 2. 2 minus 1.7 is 0.3. So fractional part of minus 1.7 is 0.3. So now I am getting fractional part of minus h. Fractional part of minus h is 1 minus h. See, fractional part of minus 0.1, I got 0.9, no? Because h is a small positive quantity, I take h as 0.1. So fractional part of minus 0.1 is 0.9. How do you get from 0.1? It is 1 minus 0.1, correct? So minus 0.1, the fractional part is 0.9. That is 1 minus 0.1. 0.9 is 1 minus that value, or 1 plus that value. 1 plus minus 0.1 is 0.9. So fractional part of minus h will be 1 minus h. Okay, limit is there still. Okay, limit is there because I have not applied limit for that fractional part. I am writing the simplified form of that. So this will be 1 minus h, bracket 1 minus h. And integral value of minus h is minus 1, minus 1, minus 1 divided by 2 into integral value of minus h as h tends to 0 is minus 1. Hope you understand. This I told many times in the earlier paper also. Integral value of minus h tends to 0 means take h equal to 0.1. Integral value of minus 0.1 is minus 1. Immediate integer less than minus 0.1 is minus 1. Integers less than minus 0.1 are minus 1, minus 2, minus 3, etc. Many other. Among them greatest is minus 1. And fractional part of minus h is bracket 1 minus h is equal to minus 4 by 3. Correct? H tends to 0 is there. No, now I can apply the limit h tends to 0 here. This will become 0 here. 1 minus 0 is 1. 1 minus 2 becomes minus 1. So alpha power minus 1. Here minus 1 is minus 2. I'll erase this part. It's not required. Already I've given the example for you. For understanding purpose it is. So what I'm getting here, after applying the limit, we get alpha to the power minus 2 plus 1. H is becoming 0. Minus 2 plus 1 is minus 1. Correct? Minus 1 is minus 2 divided by minus 2 plus 1 minus 1. H is becoming 0. Minus 2 plus 1 is minus 1 is equal to minus 4 by 3. Correct? Cancel this minus on both sides. Alpha power minus 1 is 1 by alpha minus 2. Correct, is equal to 4 by 3. I'm getting like this, correct? So from this we can simplify and get the value of alpha. Alpha power minus 1 is 1 by alpha minus 2. Take LCM here, alpha. So you get 1 minus 2 alpha, correct? 1 minus 2 alpha is equal to 4 by 3. On cross multiplication, you can simplify it and get the value of alpha. Any mistake has happened here or what? Alpha plus 1, 2 minus 1. Oh, I think there was a mistake in the question. It's not minus 4 by, it's alpha minus 4 by 3. Small mistake has happened in the question, okay? Yeah? Is equal to alpha minus 4 by 3 here. Make a correction here. It's alpha minus 4 by 3. That's what I've seen. Something mistake has happened. Please correct it. The question is equal to alpha minus 4 by 3 here, okay? Alpha minus 4 by 3. This part. So alpha minus 4 by 3. This everything is correct. In the question there is a small mistake. It's alpha minus 4 by 3 is equal to alpha minus 4 by 3. So this is alpha power minus 1 is 1 by alpha. 1 by alpha minus 2 by minus 1. That will be 2 minus 1 by alpha. Correct? Is equal to alpha minus 4 by 3. Or you can rearrange the terms. We get 2 plus 4 by 3 is equal to alpha plus 1 by alpha. 2 plus 4 by 3 will be 10 by 3. Correct? Here you take LCM alpha. This will be alpha square plus 1. Cross multiply. We get 3 alpha square plus 3 is equal to 10 alpha. Or you can write this as 3 alpha square minus 10 alpha plus 3 equal to 0. Factorize it. Adding you should get minus 10, multiplying you should get 9. So 3 alpha square minus 9 alpha minus alpha plus 3 equal to 0. 3 alpha is common. We get alpha minus 3 minus 1 into alpha minus 3 equal to 0. This gives alpha minus 3 into 3 alpha minus 1 equal to 0. That means alpha equal to 3 or alpha equal to 1 by 3. So integral value of alpha is 3. Required answer is 3. Small correction here is equal to alpha minus 4 by 3. That was missing in the question. Okay, I corrected it. In the solution, I have given it properly. The solution is correct. It's given alpha minus 4 by 3. In the question, there is a small mistake. So integral value of alpha is 3. Two possible alpha values we get. One is 3, other is 1 by 3. They ask integral value of alpha. Detailed solution is given. Learn how to evaluate the greatest integer function and the fractional part function. That is so important in limits. Concepts of limits are useful in continuity also. Don't forget limits. All we got interlinked topics, limits, continuity, differentiability, etc. My synopsis book is there. It's very useful book actually. I've written various books for PU syllabus, maybe NCERT syllabus, PU board syllabus, and also various competitive exams. I've written a book, okay, for first PU and second PU. CET book is there, and also synopsis book is there, complete synopsis. It includes all the formulas of both first PU and second PU. NCERT syllabus for various competitive exams are given, all the shortcuts and time saving results are given. Okay, it's called Achievers Mathematics. I'm the author of that book called Achievers Mathematics. It's a very famous book. Okay, I have vast experience of teaching the mathematics for PU students for various competitive exams, trained many students over the years, and started recently my YouTube channel, Abhiram's Maths Marathon. Okay, please support me, subscribe to my channel, forward to your friends also. Even if for teachers also it's useful. So learning is always never ending, we call. You can learn, you can gain knowledge by listening to my classes always. The solution is given to you. I think one more question is there, last one. This is limit x tends to 1, sine of 3x squared minus 4x plus 1 minus x squared plus 1 divided by 2x cubed minus 7x squared plus ax plus b is given to be equal to minus to find the value of a minus b. Numerical type question asked on 28th of June, second shift 2022. See, as x approaches to 1, numerator tends to 0. See, as x is approaching 1, what happens? Numerator is becoming 0, correct? Numerator tends to 0, putting x equal to 1, 3 into 1 square, 3, 3 minus 4, minus 1, minus 1 plus 1, 0, sine 0, 0, minus 1 plus 1 becomes 0. Numerator approaches to 0 as x approaches to 1. So if numerator is becoming 0, I insist the condition that denominator also should become 0, correct? If numerator approaches to 0, if denominator is non-zero, 0 by 5, or some, denominator is some non-zero number you take, denominator is 10 you take. 0 by 10 how much? Numerator is already becoming 0 when you apply the limit. When you apply the limit, numerator is becoming 0, denominator is say non-zero, 0 by non-zero is 0. That becomes left hand side is 0, right hand side is minus 2, becomes a contradiction. So we insist the condition that denominator should become 0, so that it takes 0 by 0 form. If it takes 0 by 0 form, we can apply L'Hopital's rule and evaluate it to get a finite answer. Correct? So as x is approaching 1, because the numerator is tending to 0, denominator should become 0. Otherwise, the given question becomes meaningless. Hope you understand. So because numerator is 0, if denominator is non-zero, 0 by non-zero is 0, 0 equal to minus 2, a contradiction to the given question. Hence, I insist the condition that denominator should be 0. What is the condition I get? See, I need to find the values of a and b. To find the two constants or two unknowns, I need two equations, right? So I should construct those two equations. That is why one condition is this, denominator equal to 0. Denominator is approaching 0 as x tends to 1. Put x equal to 1 and equate it to 0, denominator. 2 into 1 cube minus 7 into 1 square plus a into 1 plus b equal to 0. Correct? This is one condition I'm getting. 1 cube is 1, 1 into 2, 2, 1 square is 1, 2 minus 7 is minus 5, so a plus b equal to 5, correct? A plus b is equal to 5, this is equation 1. Another condition I can get by using 0 by 0 form, because already numerator is approaching 0, denominator is approaching 0, it takes 0 by 0 form. Can apply L'Hopital's rule, takes 0 by 0 form, takes 0 by 0 form, so apply L'Hopital's rule. Differentiate numerator and denominator separate. Apply L'Hopital's rule. What we get? Differentiate the numerator and denominator separately. L'Hopital's rule says that you should differentiate the numerator and denominator separately. Derivative sign is cos. Apply chain rule there. Cos of 3x square minus 4x plus 1 into derivative of 3x square minus 4x plus 1. Derivative of 3x square is 6x. Derivative of 4x is 4. Derivative of 1 0. Derivative of x square 2x. Derivative of 1 0. Divided by denominator. Derivative of 2x cube is 6x square. Derivative of 7x square is 14x. Derivative of ax is a. Derivative of b is 0 is equal to minus 2. Correct? See, look at the numerator. As x approaches to 1, 3 into 1 square 3, 3 minus 4 minus 1, minus 1 plus 1 0, cos 0 is 1. Here 6 into 1 6, 6 minus 4 is 2, 2 into 1 2, 2 minus 2 0. Numerator is becoming 0. So again the condition, denominator should become 0. As x approaches to 1, what is happening? Numerator is approaching to 0, correct? Put x equal to 1 directly. 3 minus 4 minus 1 plus 1 0, cos 0 1. Here 6 into 1 6, 6 minus 4 2, 2 into 1 2, 2 minus 2 0. Numerator is approaching 0, so denominator should tend to 0. Correct? Denominator should tend to 0. Otherwise, same story as I explained earlier. Numerator is becoming 0, denominator is non-zero. 0 by non-zero will be 0. 0 equal to minus 2 becomes a contradiction. So we insist the condition that denominator should be equal to 0. Put x equal to 1 in the denominator and equal to 0. What do you get? 6 into 1 square minus 14 into 1 plus a, that should be equal to 0. 6 minus 14 is minus 8. A is equal to 8 I'm getting. Put a is equal to 8 in equation 1. We'll get the value of b. Put a is equal to 8. Put a is equal to 8 in equation 1. What do we get? B is equal to 5 minus a. Correct? 5 minus 8. That is equal to minus 3. Therefore, we got the values of a and b. What we need to find is a minus b. A is equal to 8. B is equal to minus 3. 8 minus minus 3. 8 plus 3. 11. That's the answer. Numerical type question. So answer is 11. Question was asked on 28th of June, second shift, 2022. So all the questions we have covered. Hope you understand this type of concept. If numerator is approaching 0, denominator also should approach 0. And another concept we had, sometimes we had as x approaches to 1, denominator was tending to 0. In that case, numerator should approach 0. So that it takes 0 by 0 form. If limit is a finite non-zero number. Okay. Limit exists also I can count in that case. So idea of limits, many questions we have done so far. There's a detailed solution given to you. Please make a note of this. Answer is 11. With this, we complete the 2022 PYQs of limits chapter. In the upcoming session, I'll be doing 2023 JEE Main limits, then 2024, then 2025, and also before 2019, the JEE Main exams were there actually, 2018, 17, 16, etc. JEE Main was started in the year 2013 actually. Before that, we had AIEEE exam. The equivalent exam to JEE was called as AIEEE. Okay, All India Engineering Entrance Exam. Okay, now they're doing as a JEE exam. 2019 onwards, they started conducting the online exam, CBT, computer based test. Before 2019 also we had JEE exams. From 2013 onwards, I can discuss some of the questions of that also. There we have very less number of questions because it was like pen and paper mode, like NEET exams, offline exam it was before that. Before 2019, there were online exams too, but it was optional for students to take either online or offline, like that. So we had very few papers actually. 2018, I think 1 or 2 or 3 papers maybe there at the most. 1 offline and 2 online, like that. But 2019 onwards, they started conducting many shifts. Many shifts were there. Like January 6th, they conduct 2 shifts, morning and afternoon. January 7th, morning and afternoon, like that. Different dates are given, okay, for different students. So one date is given to a particular student and he has to take that exam, like that it is. Before that, offline and online, both type of exams were there. Both the modes they were conducting, and optional it was for students. Either they can take offline or online. But those questions also we can discuss. And one more thing I'm telling you is, if you're preparing for JEE exams, also study the JEE Advanced exam papers, okay, PYQs. I'll be doing JEE Advanced papers also one by one, because many times recently we see the JEE exam papers, they're taking the questions from JEE Advanced papers. JEE Advanced PYQs, similar type of questions are asked in JEE Main exams also recently. So you prepare JEE Main as well as JEE Advanced together, so that it is helpful for you, okay, to crack few of the questions. PYQs of JEE Advanced, if you see, some of the questions are almost same. Such JEE Advanced PYQs are appearing in JEE Main recently. Okay, that also we'll discuss. With this, conclude. Please, thank you for watching and subscribe to my channel. It's useful. I'll be doing all the PYQs of JEE and also various competitive exams. It may be Comet K, KCET, BITSAT, MAE exams, even VIT, Triple E. All such exams will do. Even IISCR also, NDA, National Defense Academy or Naval Academy, all one by one. I'm a beginner, YouTube beginner actually. I have a lot of experience. I'll be covering all the PYQs of various competitive exams and also many more questions I'll discuss which is not appeared in the exam, which is important also. Such questions I'll discuss, and also I'll send the notes also in the Telegram group also I'll send, and also I'll upload it in YouTube also, all the PDFs. Okay. Hope you understood all the concepts, all the solutions. We have solved the PYQs of 2022 in this session. In the upcoming session, I'll be doing 2023, then go to 2024, 25, then go to continuity. Like that, after finishing limits, I'll go to continuity, then differentiability, methods of differentiation, then application of derivatives, integrals. There are indefinite and definite integrals, then application of integrals, then differential equations. Like that, we'll complete the calculus part, then go to algebra part. We got binomial theorem, sequences series, complex numbers, one of the interesting topic, quadratic equations, correct, matrices, determinants, vector algebra, three-dimensional geometry, conic sections, straight lines, probability, permutations and combinations, trigonometry, statistics. All the topics will cover one by one. With this, I'll conclude. Thank you.